Hello, I'm Valmikam Karthik and I'm here to present my paper on opinion mining on emojis using deep learning techniques. Overview. Opinion mining is a trending research topic right now. These techniques are used to know the status of the performance of a business product or the way in which information is spread. It is recently also being used in the domain of journalism to know the pulse of the people in a famous public action. Even with such huge applications, opinion mining has been restricted to text mining. So the whole purpose of this paper is to provide insight into mining opinions through emojis on the Twitter platform using different techniques. The research methods used are machine learning classifiers, artificial neural networks, and convolutional neural networks. So through this analysis, the emojis and the text of a tweet are mined separately, and then the polarities are aggregated to generate the complete polarity of the opinion that is conveyed in the tweet. A relation between the text polarity and emoji polarity is found to detect cases of sarcasm in some tweets. The main motivation for this paper are these emojis you see. Emojis, which are powerful tools of expression, have a huge impact on the opinions that people express. Such powerful tools have not been explored and utilized for mining opinions. The difficulty in mining emojis is relatively much easier than that of mining texts. Even then, the research done in mining opinions through emojis is very less. This was the main driving force behind the paper. And this paper aims to provide an insight in mining opinions through emojis using different machine learning and deep learning techniques. Method or procedure. The procedure involves 6 major steps in order to classify the emojis, polarize the text, and finally aggregate the polarities. So these 6 major steps are applied to the tweets that are extracted from the Twitter platform. So the first step is extracting emojis from tweets. So tweets in Twitter, they were accessed by using the Twitter API of Python, and a search was made for tweets of a particular hashtag, for example hashtag iPhone, through the TweetPy cursor, and then the tweets were obtained. And different components of the tweet like the text, date, number of retweets, etc. were fed into different columns of a single pandas data frame. From the text component of the tweet, the emojis were then extracted by their Unicode and were put in a list. So tweets without any emojis were discarded. So due to the restriction that was provided by the Twitter API, the number of tweets that can be retrieved at a time were less in number. Therefore, the tweets were continuously added to a CSV file. Then, an additional procedure was required for machine learning classifiers and artificial neural networks. All the emojis in the tweets were converted into a special code known as the emoji code. So to convert into that emoji code, the UTF code of the emojis were converted into the ASCII form, and then the code was formed. Training. In this step, various machine learning classifiers and neural networks were trained. The neural networks that were used were artificial neural networks and convolutional neural networks. So in training the machine learning classifiers, we have used a 10-fold cross-validation technique to evaluate different machine learning models on this particular training set, and the validation size was 0.5 or 50% of the whole data set. Once the cross-validation was done, the model with the highest accuracy was chosen to predict the polarities of the emojis. Training the artificial neural network model. To train the artificial neural network model, we have created a neural network that has 2 hidden layers and 1 output layer. The optimizer used was the Adam optimizer because it makes use of the first and second moments of the gradients for the weights. So this helps to achieve good results in a faster amount of time. The default parameters were used for the optimizer. Training the convolutional neural networks. 109 emojis that were pertaining to major emotions were downloaded as images in the PNG format. So these pictures were hand classified into 9 major polarities which range from -4 to 4. So using these images as the training set and another set of similar but slightly different images of emojis as the testing set, the convolutional neural network was trained. And this was done in the Keras library of Python. The hand classifying emoji polarity was a basic or a simple classification, manual classification of emojis. Prediction. So the following classifiers and neural networks have predicted the polarity on the tweets that were extracted in the first step. So a single tweet consists of several emojis, and all these emojis were extracted into a list and were fed to the machine learning classifier with the highest accuracy. Similarly, all the emojis that were extracted were fed to the artificial neural network. In the case of convolutional neural networks, the previously extracted emojis from the tweets were mapped to their image file in the all emojis folder using the CSV file. So the convolutional neural networks was then fed with these image paths which link to those images in order to predict the polarity. So all these several emojis were extracted into a list and were fed to the CNN separately, and then the average of all the polarities consisting in a single tweet was taken and was assigned as the combined polarity of all the emojis in a single tweet. A standard and basic text mining classifier using natural language processing has been used to obtain the polarity of the text in the tweet. The text blob library on the Python platform was used to mine the text. For a single tweet, the text is mined, and the polarity of the text was stored in a separate column alongside the emoji polarity. Aggregation. So once the polarities are obtained, both the text polarity and the emoji polarity were first normalized into a range between -1 to 1, and then they were aggregated, and the final aggregated value represented the final polarity of the tweet. And once we have obtained the final polarity of a certain tweet, the tweet was then classified into positive, negative, or neutral. So if the polarity is positive, the tweet is positive. If the polarity is negative, the tweet is negative. And a tweet is considered neutral if the polarity is 0. Based on the accuracy that was acquired from the machine learning classifiers, artificial neural networks, and the convolutional neural networks, an analysis was done separately in order to determine the best way to predict the polarity of the emojis. So the diagram that you're seeing here right now is the analysis of machine learning classifier. All the classifiers were analyzed on the Python platform using a 10-fold cross-validation algorithm to find the best model to polarize emojis. Due to the lack of the number of parameters or technical parameters that an emoji contains, these machine learning classifiers, they tend to perform on a mediocre level. So as you can see, the highest classifier, or the classifier which has the highest accuracy, is a support vector machine. And this figure actually explains the poor performance of the machine learning algorithms on polarizing the emojis. And this this particular table, we have precise values of the accuracy of each of the different or various machine learning models. For the analysis of deep learning models and search-based classifier analysis, we have taken two different neural network models and a simple search-based classifier. So as we can see, even the artificial neural network couldn't give more than 50% accuracy. But the convolutional neural network, it has given us around 97% of accuracy. And obviously, a simple search-based classifier which is manually assigning the polarities to an emoji will definitely have 100% accuracy. Evidently, we can easily say that it is not advisable to use the machine learning classifiers or the artificial neural network model for polarizing the emojis. But the convolutional neural network and the simple search-based classifier can be used. Even though convolutional neural network gives us a high accuracy value, the time that is required to train a convolutional neural network is very high. Therefore, the most efficient method is a simple search-based classifier that will manually assign emojis, polarities to the emojis. By analyzing the results for around 7,000 tweets through the convolutional neural network and the mentioned search-based classifier, a small yet impactful finding was discovered. So one of the tweets which actually read the following sentence: eagerly waiting for Apple to drop the new iPhone like I can afford it. So we can clearly say that this particular statement is a sarcastic statement. So when we actually got the text polarity and the emoji polarity, they had two different signs. The text polarity was negative and the emoji polarity was positive. So this striking difference between the text polarity and the emoji polarity gave rise to a potential for the existence of sarcasm. So when we checked, majority of the tweets which had different signs for text polarity and emoji polarity had a tinge of sarcasm in their tweets. In this way, sarcasm can be detected, but the only drawback is that this works only with tweets that have emojis, and it cannot be detected by using plain text. In conclusion, the polarities of the emojis were obtained by training the machine learning classifiers, which gave us a very poor accuracy. The polarities were also obtained through convolutional neural networks, which had a high accuracy and a relatively high training time. Therefore, they were not computationally feasible to use for emojis. Therefore, the most efficient way was manually assigning polarities to the emojis, or a simple search-based classifier. So all the tweets that were obtained from the Twitter platform were on a specific topic or product, and the polarities for all the emojis in a given tweet was mined using the above mentioned methods, and the text was mined using a natural language processing library, which is text blob, which had a basic polarization of text. The tweets that were taken from the Twitter platform were actually on a specific topic or product, and the polarities for all the emojis in a given tweet was found through the above mentioned methods. So a normalized polarity was acquired for each tweet, and the text in the tweet was mined using a standard natural language processing method. And the analysis of 7,000 such tweets led us to find sarcasm in some of the tweets. So the sarcasm detection was found. The sarcasm was found when there was a striking difference between the text polarity and the emoji polarity. So the impact and importance of emojis in expressing the opinions that people have is increasing at a rapid rate, and in order to make the most out of their opinions, there is a huge need to find more technical attributes for emojis, which will help the machine learning classifiers and the artificial neural networks to perform better in polarizing them. So this is an open question worthy of pursuing in the future. Thank you very much.